Hello, this is a homework walkthrough for the suggested problem set number 1.1, which is Unit 1. So we'll kick right into it. So this is problem 2.1 out of the quantitative exercises in chapter 2. So it says a car travels in the positive x direction on a straight and level road. For the first 4 seconds of this motion, the average velocity of the car is given as 6.25 meters per second. How far does the car travel in 4 seconds? So if we use our definition for average velocity, we know that average velocity is change in x over change in time. So if I rearrange this really quickly to find out how far a car would travel, I would simply turn this into delta x, which is displacement, is equal to v average x times delta t. So at this point, it's simply substitution. So I have for average velocity x, 6.25 meters per second, times my time, which in this case is 4 seconds. And I should get, going to a calculator, 25 meters. So you can see that seconds in this case will cancel out, leaving me with just units of meters. Moving on to problem 2.4. Starting from a pillar, you run 200 meters east, which we are defining as the positive x direction. So I'm going to go ahead and draw. Here's my pillar, and then 200 meters east, somewhere over here. And this is my positive x direction. At an average speed, so I will point out this is speed, of 5 meters per second. Then you run 280 meters west. So I'm assuming where I stopped moving. So I run 280 meters west, which is the opposite direction, at an average speed of 4 meters per second. So I'm actually going to start including this. So I'm going to say this is at a speed of 5 meters per second. Then when I run to the left, I'm going at a speed of 4 meters per second to some other post. So we'll just say it's a post down here. A says calculate your average speed from the pillar to the post, so from the start to the finish. And so how are we going to calculate an average speed? Well, we need to recall that the definition for average speed is going to be the total distance traveled, and I will point out that this is distance, not displacement, the total distance traveled divided by the total time that you are traveling. So there's an intermediate step that I recognize at this point. I don't have any information related to time at this particular juncture. So what I need to do is I need to figure out how long it takes me for the first leg and how long it takes me for the second leg. So my first time is going to be, well, if I use my definition for velocity, I can think of that as I did in number 1, velocity, in this case, use my definition for velocity to do this. I'll start with the definition, which is delta x over delta t. And I can see that for the first leg, if I rearrange this, the time that it takes is going to be equal to the distance I'm going divided by the speed. So for the first part, t1, that's going to be 200 meters. And I'm going to divide that by my speed of 5 meters per second. In this case, since I'm only going in one direction, I don't really care about the sign. My time should be just a scalar value. So time for the first leg should be 200 divided by 5, which is 40 seconds. For the second leg, that's going to be a distance of 280 meters divided by a speed of 4 meters per second. So my time for the second leg will be 70 seconds. So now I have my 2 times, and I can go in and now calculate my average speed. So my average speed will be total distance, which will be 200 plus 280 meters divided by the total time, which will be 40 plus 70 seconds. So my average speed for this entire ordeal is going to be 480 divided by 110, which if I tell my calculator to give me an exact answer, will be approximately 4.36 meters per second. So you're asking probably, why did I not just stick with two significant figures? Well, I'm not going to worry too much about them because I'm given a number here with one significant figure in it. So I'm not going to worry too much about it. This is a very representative number, I feel, for the average speed over this time interval. Now B asks for average velocity, and so the difference for this will be very easy to see. My average velocity for this x direction motion is going to be total displacement over total time, and my displacement will be just this bit, where I'm looking at the difference between my initial position and my final position. So that is going to be, if I'm thinking of this as my 0, simply a distance, or a displacement rather, of negative 80 from my origin. So my delta x in this case is going to be negative 80 minus 0, and that is meters. And the total time should be the exact same, 110 seconds from part A. So my average velocity in the x direction is going to be negative 80 divided by 110 seconds, which gives me approximately this should be negative. My eraser is not working. Approximately negative 0.73 meters per second. So you can see the difference between speed and velocity in this example. Moving on to question 2.5. Starting from the front door of a house, you walk 60 meters due east to a windmill, turn around, then slowly walk 40 meters west to a bench where you sit and watch the sunrise. So this is a very similar problem to what we just did. So we'll start at some door. We will walk 60 meters east, and I'm going to say east is still to the right. Then I slowly walk 40 meters west at a different speed, because the first leg takes me 28 seconds to walk. So I'll say this is my T1. And the second leg takes me 36 seconds to walk. So for the entire trip, I want to calculate average velocity and average speed. So I will do average velocity first in this case. How am I going to do this? Well, I only care about the difference between my starting and ending points if I'm caring about velocity. So from a coordinate standpoint, if, again, my initial position is my origin, I only end up positive 20 meters from the origin. So my average velocity in this case will just be positive 20 meters divided by the total time it takes for me to do this. I should actually write out my formula before I do this. So delta x over delta t, that will be positive 20 meters, as I said, divided by my sum of time. So that will be 28 seconds plus 36 seconds. So my average velocity for this entire travel time is going to be 20 divided by the sum of 28 and 36, which works out to be approximately positive 0.3125. I'll go ahead and write the whole thing, meters per second. Now going to the average speed, I have to do a little bit more work again. But I have, in this case, a total distance traveled of 60 meters. So this is total distance now over total time. And so my total distance is just going to be the sum of my two legs, which is 60 meters and 40 meters. And the total time will be the exact same we had up here, 28 plus 36 seconds. So my average speed for my sunrise watching is going to be 100 meters divided by the sum of 28 and 36, which works out to be approximately 1.56 meters per second. So you can see you end up with very different values for velocity averages and speed averages.